So this video is going to be an introduction to the mechanics of working with partial fractions. So there are going to be some problems that are going to have rational expressions in them, and we're going to need to rewrite that expression in terms of smaller degree denominators so that we have a sum or a difference of two different rational expressions. This process is called decomposing or a decomposition using partial fractions. For example, just sticking with some simple numbers, 11 over 12. Well, there's another way that we could write 11 over 12. We could write that as 8 over 12 plus 3 over 12. And then I could reduce those two individual fractions to get 2/3 plus 1/4. So 2/3 plus 1/4 is the decomposed version of 11 over 12. Now I know there are other ways that I could have written this expression, lots of other ways actually, but this is just one. The problems we're going to do are going to be rational expressions with variables, so there will be only one way to do it. Here's the basic process. The first thing you're going to do is factor the denominator completely. Our examples are going to be limited to having just two factors in the denominator, just because we don't have a lot of time to do anything else. Alright, once we do that, we're going to write a new rational expression. It's going to be a sum or a difference. The degree of the numerator must be 1 less than the degree of the denominator. So, if I had a factor of x plus 3 in the denominator, I'm going to write just a plain old a on top of that. Because a is a constant, has a degree of 0, and the degree of the denominator is 1. But if I have a quadratic denominator, x squared plus 3, the degree of the top has to be 1, because that's 1 less than 2. So I would need ax plus b, a linear factor. So if you have a linear factor on the bottom, you have a constant on the top, a generic constant, so give it a letter. If you have a quadratic factor on the bottom, then you're going to need a linear factor up top. So it's going to look sort of like ax plus b. Once we do that, we're going to get a common denominator. Again, since we're only going to have two factors on the bottom, all we're really going to need to do is cross multiply in order to get that to work. And then we're going to write and solve a system of equations by setting the numerator of our new expression equal to the numerator in the original. So I'm going to show you two, hopefully, quick examples. Number one, we're going to decompose 13x minus 11 over x squared minus x plus minus 20. So the first thing we need to do is we need to factor this. So when I factor this, I'm going to get x minus 5, and then I'm also going to get x plus 4. Now I'm writing a little bit of space because I'm going to write this as the sum of two separate rational expressions. So I factored the denominator, and the factors of the denominator are x minus 5 and x plus 4. Since they're both linear factors, the top I just need constants. So I'm going to have a on top of one and b on top of the other. And we're going to figure out what a and b are so that when I get a common denominator and add, I end up with 13x minus 11 on top. So we're going to cross multiply to get a common denominator. So I'm going to do a times x plus 4. And I'm going to add on b times x minus 5. Now that would all be over the common denominator of x squared minus x minus 20. So let's write that. And then that is equal to the original problem. 13x minus 11 over x squared minus x minus 20. So now I can kind of ignore the denominators altogether and just do the numerator equal to the numerator. So in doing that, we're going to end up with ax plus 4a, so I'm just distributing, plus bx minus 5b is equal to 13x minus 11. So now we want to group things. I have an ax and a bx, and that will be equal to my 13x. And I have a 4a, which is a constant, and a negative 5b, and that will be equal to my constant. So I have x times a plus b plus 4a minus 5b. And that's going to be equal to 13x minus 11. So here's my system. The coefficient in front of x here is equal to the coefficient in front of x here. So a plus b has to equal 13. And then my constant term here has to be equal to my constant term here. So 4a minus 5b is equal to negative 11. So we are going to solve this system. I'm going to use elimination. So I'm going to choose to eliminate the b's. So I'm going to take that first equation and multiply it by 5. So I'm going to have 5a plus 5b is equal to 65. And my second equation was 4a minus 5b equals negative 11. If I add going down, the b's will cross off, and I'll be left with 9a equals 54. Divide by 9, and you get a equals 6. Since a is 6, that means b must be 7, because we had a plus b was equal to 13. That's how I figured this guy out. So the answer to this problem, so the answer will be a over its factor, x minus 5, plus b over its factor, x plus 4. This is equal to 13x minus 11 over x squared minus x minus 20. So this is the decomposition. Alright, so on to problem number 2. We're going to try to decompose 26 minus x over 4x squared minus x minus 5. So the first thing I need to do is factor the denominator. So we need to come up with factors of 4x squared minus x minus 5. And again, we're going to write this as a sum of two fractions. So when I look at 4x squared, I can either have a 2x and a 2x or a 4x and a 1x. Since this in the middle has an odd number, that tells me I can't use 2x and 2x. So I need a 4x and a plain x. And then factors of 5 are 5 and 1. I'm going to put the 5 here and the 1 here and see if that works. So if I were to FOIL this, I would get 4x and 5x, which I can make into a negative 1x if I have negative 5x and positive 4x. Or positive 1 to get the positive 4x. Okay, so now since these are both linear factors, I put an a on the top of one and a b on the top of the other. So the next step is to try to put them back together to get a common denominator. So we're going to cross multiply. So we're going to do a times x plus 1 to get ax plus a. And then we're going to add on b times 4x minus 5. So I have plus 4bx minus 5b. All of this is over the common denominator of 4x squared minus x minus 5. And this is equal to the fraction in the original problem, 26 minus x over 4x squared minus x minus 5. And now we're going to try to set corresponding elements or coefficients equal to each other. So I have, if I just kind of get rid of the denominators for a minute, what I have here is ax, I'm going to reorder, plus 4bx, and then plus a minus 5b. And that's equal to 26 minus x. If I factor out the x here, I'll be left with x times a plus 4b, and then I have plus a minus 5b. And that's equal to 26 minus 1x. Now, why am I writing the 1 there? That's because this is the coefficient in front of x, this is the coefficient in front of x, they're equal to each other, so I get a plus 4b must be equal to negative 1. And then I have my coefficient here, my constant equal to my constant here. And my second equation is going to be a minus 5b is equal to 26. So now I need to solve this system. Again, I'm going to use elimination. You could use substitution if you wanted to. It'd be easy enough to do here. But it's also very easy to eliminate the a's right away. So I have, again, just rewriting the problem here, a plus 4b equals negative 1, and a minus 5b equals 26. If I go ahead and subtract these two equations from one another, the a's will cross off, and I'll be left with 4b minus negative 5b is 9b. Negative 1 minus 26 is negative 27. So b must be negative 3. And then if I go back up here, a plus 4 times negative 3 minus 12 equals negative 1. So a must equal 11. So that means that if I want to write my final answer, the a was an 11, and the factor beneath the a was 4x minus 5. And then I have plus b is negative 3 over, that was over x plus 1. And that is equal to 26 minus x over 4x squared minus x minus 5. One thing I want to point out, plus a negative, if you wrote that, I'd probably be okay with it, but I would prefer that you write it as 11 over 4x minus 5 minus 3 over x plus 1. So this would be your final answer for the decomposition. That's it.